welcome to our two studio guests today and to fellow travelers out in cyberspace. Thanks to that non-stop stream of zeros and ones. My name is Peter Gobetz, co-founder of the Zero Project and moderator of the International Conference/Workshop on Zero. The Zero Project is a three-stage affair. There's a book project, there's this associated online event, and then there's the in-depth research program. Today, session number 1. We welcome two of the contributors to the monograph on Zero book project, Dr. Bhaswati Bhattacharya, Senior Fellow, Göttingen Institute, Germany, and Dr. Paul Ernest, Emeritus Professor, Exeter University, United Kingdom, who will present and discuss their papers to get us off to a flying start. Appropriately, the Zero Project subscribes to the very methodology that they themselves observe, as will become apparent while we proceed. Bhaswati, may I invite you to introduce yourself and give us a brief presentation of your paper, please.
Thank you, Peter. I'm a historian by training, and I work on different aspects of social and economic history of India and the Indian Ocean, early modern, for example, early modern merchant diaspora, Indian Ocean commerce, global commodities, and their adaptation, especially the adaptation of coffee in South Asia. I also work on some aspects of Indo-Dutch relationship. Today, I'll be talking about the Zero, if it is viewing the Zero as a part of cross-cultural intellectual heritage. I would like to thank the Zero Committee for giving me this opportunity to address the gathering today. I feel like an odd person out among the speakers enlisted. I'm neither an Indologist nor a mathematician, a historian of mathematics, or a philosopher. Indeed, it is a terrain where I'm an interloper. That role allows me to trade with you some of the ideas common in the area I represent, humanities. To be more specific, the social history of early modern and modern India. I shall cast a look at the way the history of Zero has been approached so far. Then I shall suggest a couple of methodologies used by historians in reconstructing the past of different salient aspects of society and culture. The historiography of the knowledge of the Zero, one of the most important findings in the history of science, and a digit essential in all arithmetical calculations and scientific computations, is often reconstructed in the context of national history. The existing literature on the Zero treats the relevant knowledge to have developed as part of the knowledge system in one country before it was gradually transmitted to other parts of the world. Although this conference is part of the project that seeks to determine the origin of the Zero, thus it is not known who invented the Zero and where. The position paper written for the Camp 02 workshop, for example, akin to the title of the Zero Project, underlines the widespread belief that the Zero had its beginnings in India. Within India, again, there is an old claim that the concept of the Zero was part of the ancient classical Indian astronomical and mathematical knowledge system written in Sanskrit. Recently, this claim has received a fresh boost due to the carbon dating of the ancient Backcharlie manuscript discovered in British India in the late 19th century. Similarly, it has been suggested that the Chinese performed decimal calculations with the help of the Chinese counting rod system as early as the 4th century before Christian era. According to Hodgkin, the rods gave the decimal representation a number the decimal representation of a number with an empty space denoting 0. Lam Lei Yong has also argued that the Hindu-Arabic numerals, including the 0, originated in the Chinese counting rod numerals. The Indians, in her view, transcribed the rod numeral system to a written version, for which they use the Brahmi script. A number system developed by the Sumerians, the first people in the world to have known having used a counting system around 4,000 to 5,000 years ago, found its way through the Akkadian Empire to the Babylonians using the system in the 3rd century before Christian era. According to some, the symbol 0 used in the astronomical data in ancient Greece alludes to its Greek prehistory. Thus, although 0 seems to have been a multi-local phenomena in the global ancient world, approaches to the study of the digit have focused on the nation-state as a framework in which it is studied. The knowledge of the 0 in these studies, as I have said above, developed within one culture in isolation from the rest of the world. Sometimes there is a stray reference to developments in other civilizations, but it definitely came from the country under study. This kind of approach has resulted in competing claims regarding the invention of the 0, who was there first, and presupposes a hierarchy in the knowledge system in question. It was developed in one culture, naturally superior to the rest, from where the knowledge was transmitted to other civilizations that were passive recipients of that knowledge. While this point of view boosts cultural chauvinism, so far no scholar has been able to present any conclusive proof that confirms the claim of a specific nation state as the finder of the 0 as irrefutable in the face of similar counterclaims. Consequently, it evokes a skepticism in the academic community at large about such claims. One remarkable aspect of the historiography of the 0 is that, apart from a couple of philosophers connecting the digit with shunyata in Buddhist philosophy, most of the writers are either mathematicians or scholars coming from other disciplines of pure science. Trained as a historian, what I miss in the studies above is an attempt to understand the socio-cultural experience in one country in view of contemporary parallel developments in other countries and the possibilities of contacts and connections amongst them informing that experience. Social experience is not static or bounded by national borders, but results from multiple socio-economic and political forces operating at translocal, transregional levels, transgressing the boundary of the nation state. Is it possible to think of the invention of the 0 as a cross-cultural legacy in view of the concept of the circulation of information and knowledge or even as a part of the process of connected histories? The revolutionization of communications technology emerging in the late 20th century makes it difficult to comprehend how information was transmitted across spatially dispersed locales in the ancient times, how knowledge was shared among ancient communities. But while nation states and national boundaries are of recent origin, civilizations and cultures were connected to the outside world and engaged with one another since the earliest times via an exchange of cultural artifacts, religion, and trade as medium. India had become a popular commercial hub in the Indian Ocean in the classical period. The periplus of the Erythraean Sea illustrates the navigation and trade from Egyptian ports to the ports in the Red Sea, along the coasts of Northeast Africa, Sindh, and Western India. Indeed, as the seals found in Sumer testify, commercial and cultural exchanges between Babylon and India to ancient claimants for the status of having invented the zero predated the periplus. Cultural, ideological, and material exchange and encounters across ethnic, linguistic, and territorial boundaries, crucial to the formation of knowledge, are as old as human history. Ideas circulate through active human agents and are often reinterpreted in a different context. Recent research has shown how astronomical and astrological knowledge circulated among dispersed communities of scholars through multiple channels over time and space, and the multifarious ways the received knowledge was continuously questioned, absorbed, or adapted to suit existing sets of local knowledge and practices at the point of receipt. Offering examples of such crisscross traffic in knowledge from Mesopotamia, Egypt, and the Greco-Roman world, India, and China, John Steele argues that knowledge in the field circulated in numerous ways in the form of written texts, through oral communication, the conscious assimilation of sought after knowledge, and the unconscious absorption of ideas to which scholars were exposed. Circulation took place among scholars of two or more spatially and temporally segregated and distinct cultures in different ways, such as a late adaptation in reworking of an earlier text. The interconnections between Hellenistic Kushana Near East and South Asia in the middle of the first millennium, enriching the societies and economies concerned, have been explored in a volume edited by Joe Cribb and Georgia Herman. Interaction between Sassanid Persia and Sui Tang China have focused on how local identity and culture were shaped by cultural others. Aspects of social experience as varied as ancient Greek visual culture and architectural style in Persia are said to have been impacted by engagement with cultures outside the country. Circulation of knowledge thus presumes that the development of knowledge may have resulted from the exchange of ideas and information and not a monocausal and monodirectional transmission in which there is no one-way input of knowledge in its fully consolidated form from one culture to another, but both and more parties contribute to it and transmit the information further as part of intellectual exchange. Moreover, the received knowledge is, as mentioned above, often adapted in a way to suit the local context. In this context, the best example of an agent of cross-boundary cultural interactions at hand is that of Xuanzang. When monks at Nalanda asked him why he wanted to return to Tang China, he replied that as Buddhism was concerned, China was a borderland on the periphery, a borderland on the periphery where the common people were looked down upon and the Dharma despised. I quote, "The Buddhas are never born in that country," unquote. He felt obligated to propagate the teachings of the King of Dharma in China. By collecting, copying, translating more than 650 Buddhist manuscripts, Xuanzang helped preserving and perpetuating Buddhism and Buddhist philosophy outside, but also in India. Some supposedly lost original Greek manuscripts of Diophantus, the mathematician and author of Arithmetica, were discovered in a library in Mesed in Iran. The Syrian Christian mathematician, astronomer physicist and translator Kusta bin Luca Balabaki, who traveled in the Byzantine Empire and collected those, among other Greek manuscripts, translated 4 of them into medieval Arabic. These are just a few examples of how knowledge travels. Knowledge travels always. Is it possible then to draw a parallel between the development of mathematics and other forms of artistic, intellectual expressions in a society? If studies confirm that cross-cultural, cross-imperial, cross-exchanges left their mark on the development of diverse cultural aspects at spatially dispersed locales in a significant manner, why should one accept the zero to be the fruit of a singular specific culture? The concept of connected histories is based on the hypothesis that there are overlaps between civilizations. Eurasia being a landmass, there is a long history of connections at different levels among the countries in this vast area. Cultural and economic exchanges between the Indian subcontinent and the Mediterranean world through Central and West Asia, for example, date at least to the Persian Achaemenid Empire, more than 1,000 years before the Baghdad Caliphate. Here, the research overlooks, that is in this methodology, the research overlooks territorial boundaries delineated by empires and states to focus on connections, movements, exchanges, influences, relations, and continuities over a long period of time. To quote Sanjay Subramaniam, a distinguished scholar of early modern Eurasia, connected histories is an approach in which the historian acts to some extent like an electrician.
Bhaswati, can you conclude, please?
Yes, I'm coming to the conclusion. Repairing the continental and intercontinental connections made oblivious by national historiographies in an attempt to render their borders impermeable. Connected histories may shed light on modes of interaction between the local and regional level on the one hand, and a supra-regional level that can also imply the global. Considered from this point of view, in the course of its life, from that of a placeholder to the one of a digit in its own right, the zero may have emerged in different contemporary ancient cultures at a border crossing intellectual capital. The trans-civilizational life history of the zero has received some attention in the works of scholars like Robert Kaplan and Amartya Sen. The task of reconstructing a local biography of an ancient phenomenon called the zero is not an easy task. Paleographists and linguists of a number of ancient languages and scripts, historians of mathematics, philosophers in different parts of the world have to combine their efforts to obtain a positive result. That is indeed what the Zero Project intends to achieve. I wish the project all success. Thank you.
Thank you very much, Bhaswati. That was right to the point. It's exactly what the project is about. More specifically, to look for hard evidence and wherever the evidence may point. The argument about circulation of knowledge and connected histories is very well taken, but even so, there's nothing preventing scholars and researchers to look for concrete, tangible evidence that may shed more light on this whole process. And that's exactly what we set out to do, because everybody else keeps just speculating so far. Thanks again. I really appreciate it, taking the time. Paul, please take the floor if you would.
Hello, I'm Paul, Emeritus Professor at the University of Exeter, where I've spent most of my career. My training originally was in mathematics, logic, and philosophy, but I became a mathematics teacher and hence sidetracked or interested in the human side of mathematics, the teaching and learning of mathematics, and spent most of my career preparing teachers, supervising masters and doctoral dissertations and theses in mathematics education. But a central part of my work has been bringing the philosophy of mathematics into mathematics education, and so it's always been a live interest. And first slide, please. So I've called my talk Naught Matters, playing on the ambiguity of zero, naught. Can I see it? Yes, thank you. The history and philosophy of zero. Now, I'm not a historian. I have no credentials in that. I have an interest in the history of mathematics, but I rely on other people's work. But I think I can bring something different by having an overview and, looking what other people bring to the table from the historical perspective, looking at the nature of zero, the nature of mathematics and the number and other systems, the structures of mathematics, and also philosophizing in a broad sense, looking at the meaning and different aspects of, mathematical matters. So next slide, please. Some of the dimensions I want to bring to bear are, most importantly, probably, is meaning theory, namely a holist or a use theory of theories of meaning versus picture theories. So I want to argue that, or draw upon other philosophers' arguments, that all signs in a system are interconnected. Their uses and their meanings, the uses determine their meanings, and that, so we're looking at the history of zero, we have to consider how it relates to the number system and also how it relates to the social contexts. And the conclusion I'll reach is that zero does not appear at one moment. It's at least 1,000 or more years while the concept develops from rudimentary components through to the full concept, which I'll come to. But I also want to draw on the semiotics of mathematics because we're dealing with signs and the relationship between signs and meanings. And I think one significant distinction I want to draw is between metaphorical and metonymic ways of making meaning with numerals. And because the metonymic is more holistic. And then the three well-known dimensions of semiotics: pragmatics, the social context of sign use; semantics, the meanings of signs; and then syntactics, looking at those signs themselves. Next slide, please. So starting off looking at the pragmatics of arithmetical signs, there are social contexts of arithmetic and calculation. Well, I want to argue that created arithmetic and calculation because of the social needs for record keeping, for taxes, tribute, trade, other meanings. There was a need for number and calculation, for taxes, for measures, for calendar. There were many practical uses in organized societies that required arithmetic. And once you have those needs, then you also need systematic arithmetic for training scribes and priests. Here's an imagined picture of some young scribes or future scribes being trained. And once you have a corpus of scribes and priests who are pursuing number, calculation, mathematics, or this restricted part of mathematics, you will get some of them, it becomes mathematics for its own sake among them, I want to argue. So you'll get, the trainers will start practicing virtuosity. And some of the exchanges I've seen between learning scribes in, say, Mesopotamia, where they poke fun at each other and say, I'm better at calculating this, you don't even know the difference between length and breadth. So there's a kind of a competition, a desire to improve these arts. Then, they're practical, but the practitioners also get drawn inwards to, through problem solving and setting each other challenges. So that's the pragmatics, the social context in which arithmetical signs derived. Next slide, please. So syntactics. Now, this is where I want to distinguish between two different strands of origins for numerals or numbers. And the earliest that I'm aware of in Mesopotamia, the use of tokens representing different quantities of specific goods. So apparently a large cone represents a large measure of grain. A smaller cone would represent did represent a smaller quantity of grain. And there were different shapes representing different goods that were traded or used. So this is metaphorical, where you have the symbol, well, it's a token, it's an object, stands for not only a certain entity that's being exchanged, but also a certain quantity of that entity. Some tokens stood for 10 sheep, I read. Now, how that relates to the origin of writing, and the scholar Shimon Bessarat argues this is the origin of writing, and it originates 10,000 years ago. That's beyond the point I'm making here. Is that first of all, you have these metaphorical representations of specific concrete quantities, and then another metaphorical representation is tally marks, where the act of counting is represented by these slashes, and then they become bundled, and so there's a picture of the quantity in the mark, in the sign, and then finally in various civilizations you have denominated numerals. For example, we are all familiar with the Roman M standing for 1,000. For example, in MMXX1 2021, our present year in Roman numerals. But these are still metaphorical in the sense that, well, it's starting to be a bit of a mix, but is that you have different tokens standing for quantities. It's no longer it's not yet a place value system. So let me go to the next slide, please. Metonymic numerals. Metonymy concerns adjacency, contiguity in signs. How different signs are placed with regard to each other, and this is very important. Now, when you look at a sand abacus, and and apparently there's evidence of them being used 2,000 to 3,000 or 3,000 to 2,000 years ago, before the Common Era, all you have are little stones, if you like, pebbles, and troughs in the sand. And I think some traces of this have been found. So here you don't represent quantity with a specific sign representing a different denomination or a different quantity of things. Here you have all these little counters that, according to where you place them, will represent different quantities. So the metonymy is the fact that it's relationships and placements that denotes the number. And we have the sand abacus, and then counting boards, and the predominant, which anticipates the abacus. Here's one from apparently 300 before the Salamis tablet counting board, 300 years before the Common Era. And again, this uses a position of counters relative to the frame and to each other to designate value. And it's the numeral as a whole that counts. So we have a holistic meaning here. Next slide, please. Next table, please. Back one, please. Yeah, and this use of the sand abacus and the counting table gives birth to, in my claim is, but I think it's easy to argue this claim, to place value notation, that instead of having temporary markers that you can shift around in places, you now start to permanently record those markers in position next to each other. And we have lots of Babylonian tablets with these are place value numerals. But initially, of course, and for many thousands of years, or several thousands of years, there was no zero. You don't need a zero, actually, if you're dealing with signs in columns, because you can just have an empty space in a column, if you have none of that denomination. And now the first time that we know, but this, of course, history is always revising, and it used to be thought to be a different origin, but currently we believe the Backcharlie manuscript is the first place that we have place value numerals, including instances of zero, that could be dated to 200 to 300 in the Common Era, but that's uncertain. And there are disputes over the carbon dating and various. It could vary, but it could be, some of it could be earlier. No, I don't think it comes before the Common Era, but there are disputes from 200 to 800 Common Era, according to different kinds of carbon dating, it's still the earliest carbon dating of some of the sheets was, I think, in the year 200 in the Common Era. Next page, please. Next slide. Now, the significance of place value is a holistic system. So you're not just looking at one sign. The sign is made up of one element of a sign. A sign is a complex coordination of several different signs coordinated by and their places matter. And once you have place value to represent number or place value numerals, you can now carry out complex calculations. Algorithms typically will work on numerals as whole systems, and once you start taking start using signs instead of tokens on a board, then you need a sign for an empty column. If you just leave a gap when you're writing numerals or other signs down, there's a danger of ambiguity, and so you need a dot, for example, or any other sign to depict, to space out the different elements of a place value numeral. And I just got a picture here because the controversy went on until medieval times, certainly in the West, between algorists and the abacists, and the abacists who use the abacus and the algorists using the newfangled place value algorithms were viewed with some suspicion until well after 1,000 in the years Common Era. Next slide, please. And I want to make an important point about algorithms for calculation. That it's certainly, where we have a lot of records are from ancient Egypt and Mesopotamia, and it appears that algorithms and calculations were done thousands of years ago, maybe up to 3,000 before the Common Era, and they long precede the introduction of zero, because if you can use place value, if you can or use counting boards, you can space out your digits, your signs, and you can just have a placeholder. So my point here is that zero as a number is not needed for calculation. So here's a simple example in modern notation-ish. If we have 1-3 representing 100 and no tens and 3 units, and we're adding that in a column way, as we teach children in school these days, adding that vertically to 300s and 110 and no units. The fact that I've put this with dashes where there's a zero, where there's an empty column, you don't need to treat any of the digits there as numbers in their own sense, in their own right. You just have to have rules for saying that, well, 3 and dash meaning nothing sort of thing, or empty space just stays 3, and then empty space and 1 stays 1, and 1 and 3 is 4. Now, in the modern way we write this with zeros, we have 103 over 310, and it's more or less the same rule that says 3 plus 0 equals 3. Digit 0 plus digit 1 results in digit 1, etc. Both column additions use identical algorithms. The spaceholder is all that is needed. So the fact that there are many cultures that for hundreds, if not thousands of years, did successful calculation with place value numbers does not mean that they had zero. You can get on very well without zero. Next slide, please. Now, moving on, that was looking at the signs, the syntactics, and I started off by looking at the pragmatics, the social context. I now want to look at semantics, the meaning of numbers or the meaning of numerals. Well, I won't go into. Numerals are just the signs, or symbols, and numbers are the meaning or those signs coupled with their meanings. The point I want to make here about meaning of numbers is as I said briefly at the beginning, I want to draw on a holistic meaning theory. W.V.O. Quine talked about the interconnectedness of meanings. He talked about scientific theories, but in general, and including mathematics. Here we have, it's not that particular words or signs denote a particular meaning. That's not the overall pattern of meaning. The overall pattern is that the whole system gives meaning to its parts and functions through their interconnections. Now, this takes a specific kind of form in Wittgenstein's meaning as use theory. Generally, and Wittgenstein dealt with other kinds of meaning as well, the later Wittgenstein regarded the meanings of signs as given by their pattern of usage as a whole, not by individual signs referring to objects, although that could be one use. My name is Paul, it denotes me. Well, it denotes me in this context, but of course in other contexts, there are many other Pauls throughout the present and throughout history. And so what I'm saying is that for me, the meaning of zero is not just the concept of nothing or the empty set, but it's the whole pattern of interconnections of numerals in place value and all the different kinds of connections, which I'll come on to more of. So I'm saying that the meaning of zero ties in with a whole lot more mathematics. It can't be looked at in an isolated way. Next slide, please. So the meaning of numbers, the meaning of an individual numeral is not just a number. So I'm reiterating in a way what I've said. So 103 means 103. No, because if I say 103, denoting the number, the place value number, I've just translated it when I say the meaning of it is 103, which is a verbal form of the same thing. It's just translation from a symbolic to a verbal or linguistically written numeral. That hasn't taken us outside the numeral system to numbers. Zero means zero. No. The sign zero means zero. No, it's just a translation. That is not the meaning of the sign. That is another sign for whatever it is that we're looking for the meaning of. And more complex even than just looking at signs for numbers and zero, the meaning of a computation is it's an algorithm with a social purpose, a socially motivated transformation of numerals with a given end. So I want to look at my meanings in a broad way, just as I want to look at the origins of zero in a broad way, taking in 1,000 years of developments. I think it's a philosophical mistake to try and pin down meanings as a simple one-to-one relationship or invention of mathematical concepts as something appearing at a certain moment in time. Things are much more diffuse and complex, is my claim. Next slide, please. So the meaning of zero does not just mean nothing, the empty count, the empty collection. Of course, those are parts of its meaning, but it doesn't just mean that. Zero gains its meaning holistically from its role in calculation and throughout arithmetic. However, the Hindu so the zero gains its meaning holistically. The Hindu concept of nothing, sunya, may well have been a necessary prerequisite for recognizing zero as a number, even though this was not needed in calculation. Next slide, please. And George Joseph gives a great overview. He's one of our speakers of how arithmetic, including zero, developed during Jain mathematics from 200 before the Common Era to 400 years into the Common Era. And not only was use of zero, but there was also negative numbers, decimal place value notation, and I think even some algebra. Next slide, please. Next, please. Thank you. So a key point in the history of zero, I want to claim, when zero arrives fully, is in the work of Brahmagupta. Around 628, he wrote this key work where he synthesizes and advances the mathematics of his day. He recognizes the vital role of zero in arithmetic as an identity element for addition, and he specifies rules for a zero and the positive and negative numbers. And I'm calling him the Euclid of arithmetic, because just like Euclid in geometry, he pulled together a lot of stuff that had been going on for hundreds of years beforehand and gave it a beautiful form and a polished, it's fully arrived. And I think Brahmagupta does that for zero. Next, please. So he gave lots of rules, which we still acknowledge, for dealing with zero as a number, for dealing with positive and negative numbers. Next, please. And in history, here's a nice picture of I think it's from Bernard of Chartres, who said, "If I saw further, it was standing on shoulders of giants." That's often attributed to Newton, but it was said long before him. And my claim is that Brahmagupta may have seen further than others, but he deployed his undeniable huge talent buoyed up by his amazing culture. And I don't just necessarily mean Indian culture, but all the cultures that contributed to the knowledge that he was able to synthesize. So I reject the great man theory of history. Individuals are nothing without their cultures. Next, please. So I've got here in this picture, kind of conceptual development. There are 4 different roots that all come together to build up zero as a number, as both an additive identity and equation solution. So in the longest column, we start off with a space in the abacus, and then an empty column in place value. Then we come to zero as a marker in an empty column, and that will feed into the relationship of zero and negative numbers and the meaning of zero. But there's also the concept of emptiness, and then zero as a number of the empty set feeds into this. We also need to have debts and subtraction and leading into negative numbers before zero can fully come into itself. And there's also the role of zero as a root of an equation. Only when you have all of these 4 dimensions has zero fully arrived. Next, please. So the full concept of zero involves all of these things. The full set of mathematical uses are required. Next, please. And so the meaning of zero resides in the uses of zero. Its role in calculation and place value, arithmetic operations, its relation with negative numbers, its role in solving algebraic equations. And I want to claim it's the linchpin that allows arithmetic to develop as a scientific theory. And we see some nice work on this in Rotman, who we'll be speaking to. Next, please. Is the concept of nothing necessary to develop zero? I've come to the conclusion it's very likely that the concept of nothing is a prerequisite for zero, but it's not for certain. So there's a question here for the history of ideas. Is it necessary to have the concept of nothing to develop zero? Do all cultures that develop zero have a concept of nothing or void? And my conclusion, based on what I've seen, is yes, it's very likely. Both Indian and Mayan cultures had concepts of nothing and developed zero. The next question, is it sufficient to have a concept of nothing to develop zero? And do all cultures with the concept of nothing or empty void develop zero? Well, looking at the ancient Egyptians, the answer seems to be no, that they, I stand corrected, next slide, please. I stand corrected that, well, this was looking at the Mayans. They had the concept of empty and zero. Next slide, please. And the ancient Egyptians didn't have zero. From Friedhelm Hoffmann, I learned that they had the idea of that which does not exist in opposition to that which exists, which seems to be pretty close to the void, but they didn't develop zero. They had this thing which is pronounced nufr, meaning beautiful or good. Although some Egyptologists disagree, it doesn't look to me like zero, even though it was put at the bottom of some double accounting sheets that balanced. And the ancient Egyptians computed perfectly well without zero, as did the Mesopotamians, Greeks, and many others. So the concept of void is at best necessary, but not sufficient to develop mathematical zero. Thank you.
It's a very good basis for further discussion. I briefly give you back and forth, say, the opportunity to ask questions of each other, Bhaswati of Paul, Paul of Bhaswati, and then we'll go to our panelist. Bhaswati, please. Have any questions?
No, only I was thinking that what do you yourself think about the debate about the Backcharlie manuscript? Do you think, because you personally think it seems that Brahmagupta was the most important
Yes.
of what, so.
Yes, because even if we acknowledge that and I did say, according to what I learned from George Joseph, that there was zero in Jain culture from 200 before the Christian era to 400 in the Common Era. The Backcharlie manuscript sort of reflects what seemed to be going around in the culture, namely zero, or certainly signs for zero. But It doesn't reflect, it shows the use of 0 in place value, but it doesn't show, as far as I know, and I'm no expert, all the other dimensions of the meaning of 0 that I was talking about. You know, the idea that it's additive identity, that it's a possible root of an equation, and you know, you could perfectly well calculate and denote numbers without you might need a sign for nothing to denote numbers, but it doesn't mean that it's a fully developed concept of 0. So if whenever the Backcharlie manuscript is dated, whether it be 200 before the Common Era or 800 after, which would be after Brahmagupta, it wouldn't change my argument, because who knows what manuscripts we haven't yet discovered or have been lost. And I very much like your point that who knows what intercultural influences there were. You know, we've divided up the world into all these empires and civilizations, given them names, but things were much more fluid. And scholars traveled around and tradespeople traveled around, learned different languages, learned different concepts, brought ideas, translated things. We'll never chart all of that, but we know it's much more complex than the simple linear developments we think, which is why I think that 0 took thousands of years to develop as a fully fledged number. It didn't suddenly appear. It took Brahmagupta to pull it all together and make that wonderful leap of that synthesis.
Paul, any questions for Bhaswati?
No, just in a way to say that I really appreciated your pan-cultural view. I think, that there are so many ways we see the past that is shaped by ideological presuppositions of the present, including colonialism and even simple geography, where we divide the world up, which is always a political act, into these, different colors and things, which doesn't reflect the true history of humanity, where things are much more emerging and shifting, and there doesn't appear to be any communication with the Mayan civilization from the
yes, that's a world apart, of course, because
yes, but we don't know yet. I remember that was part of the Kon-Tiki expedition was looking at, could there have been influences from India to the Mayans or the Incas or whoever. So that was a brave experiment. But I fully appreciate you seeing these connections and trying to stop certainly any silly nationalistic claims to be the first.
Thank you, Paul. Thank you, Bhaswati. We're lucky today to have unexpectedly a panelist that who has volunteered his services, is Dr. Victor van Bijlert, formerly just retired from the Vrije Universiteit Amsterdam. Victor, you have listened to both speakers. Do you have any questions for either or both?
Of course, both contributions are very interesting and engaging. I must say that in Paul's presentation, some of the slides went so fast, flew by, that I actually couldn't read everything that was on the slide, but that's not a big problem. I'm not sure if I could actually ask many questions. I have some question about this Backcharlie manuscript, or maybe a remark rather. I've looked at the pictures. You show a picture of one of the pages, or one of the. I would tend to, just from the little I know of the script that is probably represented there, it looks far more recent than to the second or third century AD. I think that's, frankly speaking, it's quite unlikely. I mean, it's maybe not impossible, but it's written on birch bark. So there are but that is in Afghanistan. There's some findings of manuscripts, of Buddhist manuscripts from Bamiyan, of which the oldest fragments probably do actually date from the 2nd or 3rd century, but the bulk of it dates from at least from this 6th, 7th, 8th century. So I think the Backcharlie manuscript may actually be rather from that period. And then talking about Jainism, they call it a culture. It's actually a religious movement, a specific widespread, but not it doesn't have many adherents. Actually, it never had, unlike Buddhism, which gained far more adherents. And I was very much triggered by this mention of Brahmagupta as the Euclid of arithmetic. I really would have to look into that in more detail to know exactly what he wrote. So that I cannot comment on that or ask questions. Yeah, I might actually. Do you? This is maybe asking too much. Have any knowledge of earlier writers on mathematics than Brahmagupta who might have been equally important?
I certainly don't have any such knowledge, and I was led very much by George Joseph, who I've known for 30 plus years, and who really has an awful lot of knowledge in this. I can only rely on secondary sources.
I understand. Yeah, actually, after all my training an Indologist, so I do read Sanskrit, but I was thinking of this of the writing of Aryabhatta. Aryabhatta is probably about 130 years earlier than Brahmagupta. And from what I know, Aryabhatta seems to have calculated the distance of the Earth to the Sun and the size of the Earth quite correctly. I mean, it does approach what we nowadays know it to be the case. Of course, he was not the first one. Aristarchus also did. And I was wondering, because neither of them probably have used zero, they still came to the right, through observation, without telescopes, obviously, to the right, more or less the right size of the Earth. The globular shape of the spherical shape of the Earth, as well as the distance from the Earth to the Sun. So I was wondering if you, as you say, you may not need zeros to or the concept of zero to make correct calculations, but is that possible?
Yeah, I think you can certainly. I think that thousands of years have passed with people making calculations without zero. And I think Greece, Aristarchus is a good case in point, because we don't believe that the Greeks had zero, but they were very sophisticated. And you'd have to do, it was obviously his calculation would be based on trigonometry, similar triangles, the shadow cast by a stick of a certain length, and then, doing a calculation. Oh, yeah, it measured at 2 different points and all that kind of thing.
At the same time of the year,
scaling up. But let me go back to what you said about the Backcharlie manuscript. What I've read about it suggests that it's made of birch bark and that they've been carbon dated to 3 quite distinct periods. Some as early as 200 or 300 in the Common Era, but some of them as late as 600 or 800. And furthermore, some of the scholarly work I've seen on it suggests that it was only the bark that was carbon dated, not the ink. So again, and I saw a nice argument, and I'm no expert, which suggested there was a continuity in the writing. So it looked like it was all written in one time, rather than different manuscripts combined. So if they truly vary in that date so much, and it was written when all the materials were present, then it has to be the latest date. So that would put it after Brahmagupta. Yes. But so then maybe we'll go back to the what's it called, Gwali? What's that? The Cambodian.
Gwalior.
I modeled them up as Gwalior. Which again, is that 700 Common Era?
Gwalior is in Rajasthan.
872, late 9th century.
All right, so it's 800 and something.
Gentlemen, these are all controversies that are raging. We're not going to solve them now.
No, of course not.
Our focus, I'm afraid, I must insist, will be on finding fresh evidence precisely to obviate some of these arguments that have raged all this time.
But then I would say that this is very much relevant, because Backcharlie was this radiocarbon dating was I mean, at least it pretended to add fresh evidence that this is going back to the early.
True. I'm aware of the arguments and counter arguments, and we've invited Oxford to participate. They are considering it, but they haven't committed yet. I've been after them for years, even before Backcharlie was tested. They're a little cagey about it. I'm not sure what's behind it. There's some controversy brewing, like you said. But we're not going to solve that here and now. It's very valid. You're right, but it's up to new generations of researchers, perhaps to in future do this carbon dating, run a second test, a third test. There are arguments on both sides. I'm afraid I must conclude because we're even running, instead of a half an hour to a full hour. There's a couple of concluding aspects to this event. We would like to ask both speakers. Thank you, Victor, by the way. And you can also reply to this because we're very curious to see if there's any trends. We would like to have you answer in a single sentence, answer the following questions. We'll start with the lady, Bhaswati. Was the numeral zero as distinct from the placeholder, the numeral zero, was it discovered or invented? One single sentence, please.
I think invented.
Okay. Paul?
Yes, I believe it's an invention. It's, like all of human language.
A single sentence.
Yes.
Victor, invented or discovered?
I think it was both.
Okay, fine. Second, we're noted this down. Second, was the distinction between the placeholder zero and the numeral zero that we've been talking about, was it a gradual evolutionary process, or was it a disruptive moment in history? Bhaswati?
Gradual.
Okay. Paul?
Yeah, gradual. There's no evidence of a sudden jump.
Victor?
I would say gradual, yeah.
Okay. And lastly, also again in the broader context of us drafting a research program, we value your input. Third question is the concept of nothingness or emptiness trivial or profound? Bhaswati?
It is profound.
Paul?
But you don't say the context. I mean, as such, it is profound.
Okay.
It's profound both mathematically and philosophically and mystically.
Sorry, I missed that. What did you say?
I said that it's profound in all both mathematically, philosophically, and in terms of mysticism or religion.
Okay, great. Victor?
I think both profound and not profound.
Okay. If you were somebody else, you might have said it's neither.
Neither profound nor non-profound. Yeah.
So thank you all for joining us. It was really a pleasure, very stimulating, and it's the first it's the first of a whole series. So again, taking the holistic view, cumulatively in retrospect, when we've seen all the episodes, we'll be able to have a better picture of where we're going. So please tune in the week after next to explore related issues, to locate, if possible, the epicenter of the invention of zero. And in doing so, again, we will help us draft a roadmap for further research. So till next week, when we meet Professor Brian Rothman on the semiotics of zero, and Jonathan Sender on, in quotes, a new and improved zero. Thank you very much. Till next week.
Thank you.